Hi everyone, this is Mr. Youngren, and welcome to actually the start of our ninth unit. Unit was fairly short. We're going to be working with quadratics. Now, before we actually jump into quadratics, we're going to extend on some of the ideas we had worked on in Unit 8, where we were working with polynomials. We're going to actually kind of undo some of those operations that we had previously done. So to kick things off, we're gonna start with an opener just like always. And it's an opener in some work that you should already know. So the opener is asking to simplify the following expressions by distributing. Now remember, to distribute means to multiply. So what you're gonna wanna do is take the term outside the parentheses and multiply it to everything on the inside. So go ahead and hit pause, go ahead and try that, see what you come up with. I will have the work shown and an explanation for you here in just a second. All right, here's what you should have after distributing. Remember, the biggest thing to remember here is that when we have a term outside parentheses, it needs to get distributed or multiplied to every term on the inside of those parentheses. I like to show this visually to myself by drawing arrows just to make sure that I am multiplying everything. So I'm drawing an arrow from 2 to both the x and the 2. There's two terms there where we get 2x plus 4. And then it's asking for our answers in standard form. Standard form means that all of our terms are written in order with the largest exponent term first, next largest exponent term second, and so forth. So that our smallest exponential or smallest term in terms of its exponent is written last. And that's usually going to be a constant or just a number. So that's why we usually see like 18 or 4 or some other number at the very end. So our second and third oral problems very similar. We're distributing, but now just two more terms. And again, everything needs to get multiplied. And then just remember, if we're multiplying variables, we're really adding the exponents. So an x is like x to the power of 1. So when I distribute that to x squared and add the exponents of 1 plus 2, that's how we get the x cubed. So the reason that we're starting out with this is our task is now going to be to undo the distribution. So if we have these answers in standard form, can we find a common term or some value or variable that we can pull out or divide out from every single term? And that's essentially what this lesson is. Now that's what this is describing here, where we say, in the problems above, all the answers in standard form share a common term. It's the term that we distributed. When we recognize that all of a polynomial's terms share a common term, we can do the opposite of distribution and divide out that common term. We call that term the greatest common factor. And it is any number, variable, or even both that all the terms have in common. Okay, all the terms is really important here because if only 2 of the 3 have an x, we can't take an x away. Okay, if 2 out of the 3 are only divisible by 2, we can't divide everything by 2. Everything needs to be divided by what we label as the greatest common factor. So let's go and put this to use. And again, this takes a little bit of number sense. It might take a little bit of practice by playing around with numbers to figure out, okay, what divides all these terms? So I'm looking at 27 and 9. And my first thought is actually to go to 3. I know that both 9 and 27 are divisible by 3. I'm like, is there a bigger value that I can divide from both those terms? Well, let's try the biggest possible that we could divide out, right? And that's 9. Because the only things that multiply to 9 are 1, 9, and 3. 9 is going to be that largest potential greatest common factor. And is 27 divisible by 9? Yes, it is. And so we're going to divide these terms by 9. And so whatever we divide both the terms by, that's our greatest common factor. So when we're working on rewriting these expressions, we want to make sure we're writing an equivalent form. So it's not that we're going to divide by 9 and just call it good. Rather, we're going to pull a 9 out from both these terms, and then we're going to put it in front of a set of parentheses. And what's going to go inside the parentheses is exactly what the result is of us dividing the terms by 9. So 27 divided by 9 is 3, and we still have our x there. 9 divided by 9 is 1. And so what we've just done is factored out the greatest common factor of 9. And we've written an equivalent expression. 9 times 3x plus 1 is the exact same as 27x plus 9, which I could check by distributing the 9 back in. We don't need to necessarily do that, right? So that's our goal with all of these. What do they all share in common? So moving along to 70n plus 10, I'm going to again jump to what is the largest possible common factor that we could use, and that's 10, right? In order for everything to get divided, we're limited by 10. Anything above 10 obviously won't divide 10 itself. And I know that 70 is also divisible by 10. So we're going to divide them both by 10. We're going to pull that 10 away, and then in parentheses write what our quotient is, or the result of dividing everything by 10. And we get 10 times 7m plus 1. And again, had I distributed the 10 back into the parentheses, we should get right back to where we started. Right now, like we said here above, is that our greatest common factor is not always going to be just numbers. It can also be variables. These are the ones that we really want to pick up on. When we start moving forward with our factoring and doing some more work with quadratics, we want to recognize if all our terms share a common variable, we want to get that out of there right away. And so when I'm looking at this, 2x cubed and negative x, there's not one number that divides them both besides 1, and dividing by 1 won't change it. So I'm like, okay, what do they then share in common? What do they both have? Well, they both have at least one x. Now, when we're dividing by x, think about what happens when we multiplied by x, right? When I multiplied by x, we added the exponent. So now if we're doing the opposite and I'm dividing by x, I'm going to do the opposite of adding the exponents. I'm going to subtract them. So x cubed divided by x is going to result in an x squared. And then x divided by x, or anything divided by itself, is just 1. So minus 1. So again, whatever we divide by goes out in front of a set of parentheses, and inside the parentheses, we're going to write down whatever the result is of dividing by that greatest common factor. And again, we can check. If I distribute the x, I get 2x cubed. If I distribute the x to negative 1, I get negative x. Now, similarly, we want to take out as many of the variables as we can. So over here, because this was just x to the power of 1, we couldn't take out an x squared or an x cubed because the x does not have that. But if we can take out more than just an x, or more than just an n in this case, we want to do that. So looking at these two terms, again, I asked myself, what do they both have in common? There's not a number, besides 1 at least, that divides both these coefficients. But n to the 4th and n cubed both have at least an n cubed. And so we want to take those n cubes away from those two terms. And so we're going to put the n cubed out in front, and then in parentheses write what is left over, or what our result would be from dividing everything by n cubed. So negative 3n to the 4th divided by n cubed is negative 3n. Again, remember, we're subtracting the exponents. 4 minus 3 is n to the power of 1, and we don't typically write to the power of 1. And n cubed divided by n cubed, well, anything divided by itself is just 1. We're all done. All right, so just these last two, now we have more terms. Again, remember that every single term needs to get divided by what we're labeling our greatest common factor. So when I'm looking at negative 8p to the 4th, 56p, and negative 56, the first two terms both have a p, but the negative 56 does not. So p is not going to be a part of our greatest common factor. In fact, it's not a common factor at all. Instead, we want to think about what number can we pull away from each. I see that I have an 8 here, and I know that 56 is also divisible by 8, so we want to take away the 8. Now, there's actually two answers we can land on here. We can take out an 8. We can also take out a negative 8. And honestly, it doesn't matter which one you ultimately decide. Just kind of for what we're going to do moving forward, if we have in our first term, or the term with the largest exponent, if it's negative, we're going to actually want that to be positive. So I'm actually going to have the common factor here be negative 8, although positive 8 would work just the same. Okay, there's nothing wrong if you do factor out a positive 8. So when I pull out negative 8, I'm left with p to the 4th minus 7p, and then plus 7. And again, I can check this. If I distribute back in, do we get that original the original equation or expression that we had? The answer is yes. Negative 8 times p to the 4th is negative 8p to the 4th. Negative 8 times negative 7, positive 56, and negative 8 times positive 7 is negative 56. So all looks good there. All right, and then our last one, I'm going to start with what numbers divide all three of these. Should be pretty straightforward. They're all 10, so we can divide them all by 10. Or we could even divide by negative 10. And I'm actually going to choose that negative 10 again, just with the intention of getting my first term to be positive. Positive 10 would work out just the same, but I want to make that first term positive, and so I'm going to pull out a negative 10. And then I'm looking at what do they all have in common? They all have v's. How many v's can we take away from each? Well, the smallest amount of v's we have is v cubed. V to the fifth and v to the eighth at least have v cubed, so we actually want to pull out a v cubed as well. So in this case, our greatest common factor is a coefficient or a number and our variable of v cubed. So we're going to write that term out. And then again, in parentheses, we're going to write what's left over. And the way that we do this is we're going to divide the coefficients by coefficients and variables by variables. So negative 10 divided by 10 is just a positive one. I don't need to write that. V to the eighth, v divided by v cubed, we're subtracting those exponents, which is a positive 1, v to the fifth, after I do 8 minus 3. Moving forward, positive 10 divided by negative 10 is a negative 1. I'm just going to write the negative. We don't need to write that 1. That's that invisible 1 that we see in math. And v to the fifth divided by v cubed is v squared. And last term, negative 10 divided by negative 10 is a positive 1. I'm just going to write positive. Again, that invisible 1 would show up. And v cubed divided by v cubed is just v cubed divided by itself, which is just a positive 1. And now we've taken out our greatest common factor. All right, that's it for this lesson. As always, make sure you complete your video check-in and have a great rest of your day.